Well, hey everybody, we've just finished Chapter 9, Section 4, which was solving quadratics by factoring. Something they like to throw in there that isn't necessarily in our textbook, but we put in there because it shows up in our EOC test, it shows up in our progress monitoring assessments, is they like to give us the solutions and have us work in reverse. So what we need to remember is that we can always reverse any process that we do in algebra. Everything has some sort of a reciprocal property that goes on, okay? 3 easy steps to do this. First thing, remember that roots, how they do these, roots, zeros, x-intercepts, they all mean the same thing. They're all solutions, okay? So we have 3 steps in which we need to do. The first thing is we need to take our 2 solutions and set them equal to 0. I'm sorry, x, not 0, x. We're always so used to setting things equal to 0. In this case, we're setting them equal to x. We're recreating our equations because they are x equals, after all, x equals 4 and x equals -2. Those are the x-intercepts. X equals 4 and x equals -2. That's step 1 complete. Step 2, we now want to put them in standard form. We want these equations to be reversed and go back to equaling 0. So if you look at these, remember we're considering this to be like 2 separate equations we're dealing with here. How do we get rid of this +4? We want to subtract 4 on both sides. These will cancel and leave you with a 0 is equal to, please be careful, these are not like terms. This is a variable to the first power and a constant. You are left with an x minus 4. And like that, look, this is a factor, one of the 2 factors that made up this original equation. Same thing here. We need to go through and we need to add 2 to both sides. Right? Remember, not like terms. These cancel and give you a 0. And on this side, you have an x plus 2 equals our 0. And again, like that, here's 2 factors. This is, again, reversing that 0 product property. Here are 2 things that multiply together that equal 0. Well, we can put them back together. X minus 4 times x plus 2 equals 0. And all we have to do is now we can actually multiply these 2 together. So good old box method is coming back into play. These are binomials multiplied by binomials. So it's a 2 by 2 box. You have an x, a minus 4. We have an x and a 2. We fill in our boxes. We got to multiply. Look up, look left. X times x is an x squared. X times -4 is -4x. This would be a 2x, -8. Once we've carefully added our multiplied to fill in our boxes, we have to add to get out. And look, the cross diagonal boxes, those are our like terms. X squared comes out, +2, -4 is with a -2x. The -8 can come out. And there was our original equation. These solutions are the solutions to that equation, so you can find your original equation. Let's look at the other 2 examples. They get slightly harder as we go because now they're left with what? We are left with fractions. It's okay. Set each one equal to x. X equals 3. And x will equal -3/2. Just like we did above, we need to subtract 3 from both sides. X minus 3. There's 1. Those cancel. This one here is a little bit more work. We have to multiply by the denominator. That helps us get rid of the fraction. So you have a 2x equals -3. And then what do? We add 3 to both sides. Again, be careful because these are not like terms. End up with a 2x plus 3 is canceled equals 0. And here's your other factor. How do we get our original equation again? All right, we just box method them back together. We have an x and a -3. We have a 2x and a 3. Multiplying to fill in our boxes. -6x and a -9. Again, notice the diagonals line up. So we pull everything out of the box. We're adding our like terms. Nothing adds with this. This is a -3x, a -9. Come outside. And there is your original. This was the original equation that when you solve by factoring or whatever means you get to, you end up with those as your solutions. Do one more example, one with all variables going on here. And I'm going to show you one way again, and then an easy way. Set each piece equal to x. And then you solve. Multiply both sides by 4. Cancel and leave you with 4x equals -7. We add a 7 to both sides. Remembering that these are not like terms. These canceled and give us a 0. Not like terms, rewrite. 4x plus 7 equals 0. I'm going to show you an easier way in this. Be careful. Take your denominator, whatever it is, and add an x to it. Take the numerator and change the sign. Bring it here. There's your other factor. So if you don't want to do all this work and you can see the process, what happened? Why did we do this? Look, the denominator comes to this side as multiplication. Then we have to do the opposite sign of this to get it to move to that side. And that's all we do. You are done. These are your factors. If you see this, right, 2x, swap the signs, you can quickly get the factors. And then all you have to do is box method your answer back together. Interesting way to look at it. It's always neat to see different ways to do the same problems. And then we have what? 4x and a 7. So you're ending up with an 8x squared. You have a -12x, a 14x, and -21. Like terms leaves you with a 2x. The -21 comes out, and the 8x squared comes out. And like that. 3 easy examples, even showing you a little trick. And you know me, I'm not big on tricks, but this does work all the time. All right, have a great one, guys. Get busy, finish up that homework.